This video is to give you a briefing about the group project of Team 21 for DIY Assignment 4. I am Surisetty Vaishnavi, one of the 4 team members, and I will take you through this video today. Our project is Automatic Vacuum Cleaner or AVC. Before I explain what our project is, I will address the need of it first. By the name of our project, it is implied that it is used for cleaning, and the common existing solutions for cleaning are tedious, like operating heavy machines or involving a lot of physical work. Here comes our AVC into action. Our project's objective is to build a robot which is autonomous, obstacle detecting, and have the ability to clean the floor using vacuum. The predominant components involved in our project are ultrasonic sensor for detection of obstacles, Arduino Uno, our microcontroller board, and Arduino motor shield to control speed and direction of the wheels. Servo motor to increase the range of detection of obstacles by rotating the ultrasonic sensor, DC motor to create the vacuum for suction, and jumper wires for connection. This is the schematic diagram of our project. The slide switch over here switches on or off the AVC. This servo motor keeps rotating the ultrasonic sensor while it detects the obstacles and sends the message to Arduino board, in which we encoded our software, which accordingly directs the movement of the wheels with the help of Arduino motor shield and gear motors. And the power supply unit for our whole project is lithium-ion batteries. The logic that is explained is present over here in the form of a flowchart. Coming to the coding part that is involved, I will explain the key parts of the code. We have defined the maximum distance, maximum speed at translation and turnings of the AVC. Over here we define the extent of the angle our servo motor should make our sensor rotate. Here we describe the criteria at which it should move or stop. In this part we define that if the distance between obstacle and AVC is greater in one direction than the other, it should opt for going in the direction with greater distance. Here we defined the functions related to signal sensing and triggering with respect to direction, functions that instruct ultrasonic sensor, and functions that direct the AVC to stop. This part of code specifically explains how each motor should work in specific situations. This part of the code defines the directionality of our AVC. Now let's see the working of our AVC. As you can see, the AVC moves constantly looking out for obstacles and applying suction at the same time. This is the top view of working of AVC. Over here, you can witness that it calculates which direction has more obstacle-less distance from it and then proceeds in that direction only. The waste is all collected in this storage unit, which is detachable, and hence it is easy to dispose the waste. Our team members are Akul Ahuja, Anshul Pathak, Raunak and Surisetty Vaishnavi. Thank you for watching.